Dr. Hammett, how's it going?
Good. Give me a few minutes here, a couple minutes.
Yeah, sure.
How so have the videos been working all right for you? I mean, are
Yeah.
they haven't been glitchy or anything?
No, the one we were talking about last time was a little glitchy for me, but the last two weren't at all.
Okay, so like the move to Zoom seemed to alleviate that problem.
Yeah, they seem fine to me.
Mm-hmm.
Okay, I have a couple students that are saying it would be better if I put them on like YouTube, so I'm trying to figure that out right now.
Mm.
Okay.
So I've uploaded here, just a sec. I've uploaded several to YouTube, and I didn't know anything about YouTube other than I go there sometimes and watch videos, but apparently you can do a fair amount in here, so that's interesting. So I may just make a YouTube channel and send that out to people as well. That way you're not bogging down your machine or something.
Okay.
But it takes a while for it to upload. So I've been trying to, throughout the day, do a little bit, like one at a time or something.
Mm-hmm.
So what do you guys have going on?
Well, we have a couple of questions from 8.2.
All right.
And then, I was also wondering, for the exam or this homework, when we're drawing out like the Rook polynomial boards themselves, do you want us to include those somehow when we submit questions pertaining to Rook polynomials?
When you submit questions.
Or I guess like the homework and the exam.
Oh, yeah, I mean, if you just draw one board, I mean, I think that's, if you just draw the board,
Okay.
Okay.
you know, and that'll just be a visual rendering of how you're thinking about it. That's fine.
Okay.
Okay.
I even found, we talked about it back when I was in La Tech, like there's a website that can like help you generate table, like the code for the tables, like you just type in, you know, the table you want. And it was handy.
Yeah.
It even let you like move around the columns, which was handy when I went to subboards. It would help me
Wow.
like I could drag the column over. It didn't do that with rows, so rows I had to like manually go in and mess with. But
Oh,
yeah,
wow. That's
that was
cool.
handy for when I was trying to, you know, figure out the code.
Well, I have, I mean, mine's probably worse than whatever it is you're using. I mean, I have like a separate LaTeX file where I coded up like, you know, boxes and locations for those boxes and things like that. I'm sure that whatever you have is way better than that, but I don't know. So, I mean, that's one reason why I said at some point that it would be complicated for me to put the notes up in tech, because I have like 14 other tech files that have specific little things. I have little subroutines I've written or something like that.
Mm-hmm.
So that PDF file that's on Canvas is, you know, generated from like 7 or 8 different tech files, I think. So, yeah. Yeah, all right. So, yeah, that's fine.
Okay.
If you just draw one board, that's all I really care about. I kind of cheated in my notes a little bit. I just made little like tables or something and put X's and then shifted things around and put more X's. But yeah, if you want to draw some cool pictures, that'd be great.
Okay.
What else? What other questions? Hey, Ilona, how are you doing? Hey, Ilona, just so you know, I am making like a YouTube channel. I didn't know what I was doing up until like a couple of hours ago, but I think I've pretty much figured it out. I've put, I think that's in the process of putting the third one up there right now. So stuff should be there pretty soon. It could have something to do with your internet connection.
Yeah, there's a couple of us in the house that are like kind of on the network all together, and so then like having to download things and
Yeah.
like
Yeah.
it's like putting us all behind. But
Right.
yeah, YouTube would be fantastic.
Yeah. Well, sorry about that. Yeah, I'll get that. I'll try to get that up there. See if that works better for you. I'll send a message out about that. Oh, hi, Hope. How are you doing?
Hi, good. How are you?
Good. Hey, I figured out, is the view different for you now?
Me?
For everyone, is it like look like a bunch of little pictures now?
Mhm.
So we can choose to alternate between speaker view or like a bunch of little pictures.
Oh, I see. Okay. Yeah. I went to the other view. I just figured that out a little while ago, so that's kind of neat. All right. Well, what questions do you have?
Oh, 8.2, number 28.
Oh, I thought you were going to say 20. Okay.
No.
Okay. 28. All right.
I mean, 20 I haven't figured out either, but Elise and I were talking about that one, and I'm going to go think about that one some more.
You guys can keep talking. I'm gonna run and get a journal. I realized I forgot to bring it in here.
Oh, okay. How many ways are there to seat in couples around a circular table such that no couple sits next to each other? Well, what do you think?
So we started, Elise and I were talking about this one earlier, and we started kind of talking it out, but it was the whole circular thing that was throwing us, because otherwise it would just be some sort of pretty normal, like, inclusion-exclusion thing where, like, A sub 1 is the set where, like, the first couple sits together, A sub 2 is the set where the second couple sits together. But we weren't quite sure how to actually calculate those sizes just because of the circular table.
Well, I think your setup is exactly what it should be, right? So,
Okay.
So, like, how many couples are there in total?
Yeah.
Right. So that means there's like 2 individuals.
Right.
So then, yeah, so like A1, so you're defining like A1 to be the number of configurations around the table where couple 1 is separated. A2 is A2 is the set of configurations couple 2 is not sitting or is sitting together. Yeah, is
Yeah.
sitting together. Yeah, is sitting together. Yeah. Okay. You kind of define them badly.
Right.
And then what you would want is you would want the size of the intersection of the complements. Yeah. I think that what would be most beneficial here is, well, first of all, how do you count the size of the universe of all configurations around the table? I think once you sort that out, you might be able to figure out the other ones. What do you think about that?
We were saying that was just 2n factorial.
I think that might be where the circular table comes into play.
Okay.
We weren't quite sure if we could just like kind of pick a spot and go from there, or kind of how that worked.
So if we could tell the difference in the chairs, so like if there was a throne in position 1 and then like a bunch of other different chairs everywhere else that weren't thrones, then we might consider like all of the ways you could rotate the people around the table as being different. So 2n factorial, 2n quantity factorial, that would count the total number of configurations where you could tell the difference in the chairs around the circular table.
Okay.
So what would be, well, how would you, what would you have to do to correct that? That's almost right.
Would you divide by n factorial to like unorder the seats?
In factorial. That's pretty
Oh, two.
that's pretty bold. Yeah.
Okay, yeah.
Yeah. So what would you divide by?
Would it be 2n factorial?
Not two, well, because 2n factorial is the total number of ways if you can tell the chairs apart around.
Okay.
Yes. So there you would be like chair number 1, 2, 3, all the way to like 2n. And you put
Oh,
six
okay.
there.
Yeah.
But then you want to think, well, like I don't want to count all those where it's just simply
Yeah.
I don't want to count those as different. So that's going to overcount by a factor of, how many ways are there to
2n.
rotate this thing around? What's that?
Is it 2n?
2n, yes. 2n. So it's 2n quantity factorial divided by 2n basically. So it's 2n minus 1 factorial. Does that make sense?
Mm-hmm.
Yeah. Okay. So that's a step in the right direction. Well, okay. And then, of course, you maybe have learned in this class at this point, but what you probably should do at this point is try to just count the number of configurations where couple 1 sits together. What do you think about that?
Would it work as a strategy, kind of like how we've done with like making super letters where you glue 2 letters together? Would it work to maybe glue 2 individuals together?
Yeah, just glue those, right, glue couple 1 together, yeah.
So then you're only counting 2n minus 1 couples.
Mm-hmm.
Or
So
wait,
that's just,
yeah.
so that'll give us a 2n minus 1 factorial over 2n minus 1. So it'll just be 2n minus 2
Factorial,
factorial, sorry. Yeah.
that's right.
And then we'll have n of those situations.
But there's 2 people glued together, and they're either going to be sitting like this or
Oh.
like that. So
Uh-huh.
that's almost right. You have to multiply by
2.
2.
Okay.
Oh my goodness.
Yeah. Well, once you see that, though, I think you might be able to see the rest. So, okay, so the number of ways for couple 1 to sit together is just 2n minus 2 factorial multiplied by 2.
Yeah.
What about for couple 1 and couple 2 to sit together?
And is it 2n minus 2 factorial over 2n minus 2? And then since they can sit in different orders, would it be times 2 squared?
That's right. 2 times, yep, times 2 times 2. Yep. You see the pattern now?
Mm-hmm.
And I think you should be able to bang that thing on the head at this point, right? You just have to write down the formula for an exclusion, and you have all the counts now. There's no stopping you.
Cool.
I may actually end up, I mean, I think this thing, I said it was due on, when did I say it was due? Monday?
Monday.
Yeah, I may extend that a couple days because Logan was kind of freaking out. So,
Aw.
that's all right. Yeah, I think he got behind because he was in London or something. I think. Yeah.
Wait, what?
Well,
Like,
he was
London, Ohio.
No.
London over spring break.
Yeah.
Wait, what? Wait, is he still there?
No.
No.
He was in London over spring break on a missions trip.
Oh.
So I think I might extend
Yeah.
that to Wednesday, and then he wants a plan. So I'm like, in terms of like what's going to work. I think the next one was due on like the 27th or something.
Yeah, it was on like Friday.
Mm-hmm.
So I may have to extend that one a little bit, but it's all right. We'll get it worked out. What else? What other problems do you have?
I had a question on point 2, number feet. I didn't really know how to set it up.
Number 3?
40.
Oh, 40. Okay. Ooh, yes. How many ways are there to deal a 6-card hand with at most 1 void in a suit? So, anybody want to speak into that one?
So I wasn't quite sure if this was right, but the way I approached this one was I said, okay, so basically it's inclusion exclusion, but if our sets are like a void in one suit, we're starting with like the two-way intersections, like the intersections of 2 sets. So you're gonna have your universe, which is the total number of ways to deal a 6-card hand. So it's 52, choose 6. And then like for say A1 and A2, you're gonna have 26, choose 6, because you're excluding the 2 suits. And then I did the same thing for like the 3-way intersection. I wasn't sure if that was the right way to approach it. Elise and I were actually talking about this one. I wasn't quite sure about that.
At most 1 void in a suit. Okay. At most 1 void in a suit. Yeah. Okay. So yeah, that might work. I mean, well, the thing is, I'm tempted, but I don't think I'm allowed to do it. I'm tempted to use the formula. Oh wait, we do know that formula, don't we? Oh yeah, we do know that formula. Like the NM star and the NM ones,
Yeah.
right? Remember, we spent all that time doing those ones. That was like the lecture. I think it might have been one of the last lectures we had in person, right? We went
Yeah.
Proved theorem 2, right? Which counts the number of ways to, so if I have a bunch of sets, it counts the number of ways to belong to exactly M of those sets, or at least M of those sets, where M is just whatever you determine it to be. Does that make sense? So how do you, I mean, I think Katie, you were describing a strategy that is probably accurate, but I think what you're doing is basically applying one of these 2 formulas in some interesting way. So how would we set this problem up in such a way that these formulas would be utilized? I was freaking out there for a minute because I was sitting there thinking, how do you do this without NM and NM star? Because it's saying at least or at most 1 void in a suit. Yeah, at most 1 void in a suit. At most 1. And I was thinking, man, I need that formula. But we have it. right? So we have those formulas. So how would you guys do it? How would you propose we do it?
So would you have like 4 sets? Like set 1 is where there's a void in spades. Set 2 is a void in diamonds.
Okay.
All the way down.
Yes. Yes.
And then we're counting, we want, so like for NM star, that would be like the number of ways to belong to at least 2 of those. And that would be like a bad case that gets subtracted.
Mm-hmm. Yeah. NM's, yeah, N2 star,
Hmm.
you would subtract that out. And then what would be left?
And then that would give you what you're looking for, the
Yeah.
ways where it would be at most 1.
So what would you subtract that from? What would you subtract N2 star from?
The
Understand how
count,
Ilona is
like the
setting this up?
universe.
You guys know how Ilona is setting this up? She's saying like A1 is a void in hearts, A2 is a void in diamonds, A3 is a void in clubs, and A4 is a void in spades or something, right? And you want to belong to at most 1 of those sets, yeah? At most 1 of those sets.
Yeah. So you're taking the count of the universe. So like of all possible 6-card hands, I guess, and then you're subtracting the N2 star, which is the number of ways to belong to 2 of those sets.
Yeah, so what Ilona is saying is if you belong to at least 2 of those, that's bad, right? Belonging to at least 2 of those are the bad cases, yeah? So you would want to subtract those from the total number of hands. So you would subtract that number from what?
From the universe?
Yeah, and what's
Oh,
this?
52 choose 6.
Yeah, that one we could count in our sleep, right? 52 choose 6. Yeah. So, okay. What's the size of A1?
So to make something with a void in hearts, you pick
Although, do I really care about A1? Look at NM star on page 335. What's the first one I would be concerned with? So I would want N2 star, right? I mean here, so I'm gonna go to my childish whiteboard here. Okay, so if I'm looking for N2 star, that would be the number of things that belong to at least 2 of these. Those are bad, yes? At least 2 of these. So that would be S2, oh my word. S2 minus S3, or minus 3 choose 2. I'm just using the formula. 3 choose 2, S3, yeah? Plus, how high am I going here?
you can only go up till like 4.
Yeah.
Well, and even that would be like a void in everything. So
M choose 2, and so this would be 4 choose, so plus 4 choose 2, S4. Is that what the formula says it should be?
Well, what is the 3 choose 2?
Because the formula is like S sub M minus M plus 1 choose M.
I think that's NM. Are we doing NM or NM star?
NM.
Oh, sorry. What should this be? Yeah, you're right. NM star, what should this be?
2. Choose.
You choose what? Sorry. And what's
You
this
choose
one?
one, yeah.
Huh? And what's this one?
3 choose 1.
3 choose. one.
But I'm pretty sure this one's going to be stupid anyways, right?
Mhm.
You can't have a void in all. S4 is going to be the sum over quadruple intersections, but that's just one thing. It's a quadruple intersection. And so what's the size of, what is this thing? What's S4?
0.
That's definitely 0. You can't have a void in all 4 suits. Right? So that thing is 0. And what about this? What about S3?
You just choose 6 cards from the 13 that would be in the one suit that's
Yeah.
allowed.
Yeah. So S3 is the size of all the triple intersections. How many triple intersections are there?
Is it? Oh, yeah, 4, choose 3.
1, 2, 3. Yeah. And they're all the same size, yes? And then you're right. You would go to the one that you're allowed to take cards from, and it would just be 13, choose 6. Yeah? And then what about this guy?
4, choose 2 times 26, choose 6, because you can pick from 2
Yeah.
that aren't voided out.
4, choose 2. You're choosing the 2 in which to have a void. Yeah? And then from the other 26 cards, you need to choose 6. And the answer is just going to be to take this away from the total number of hands, yes? This gets rid of all the hands. This gets rid of all the hands where we have a void in 2 or more suits. Make sense?
Yeah.
I think, Katie, you may have, like, you probably, I think maybe the formula you were telling us is actually right. What did you say?
I had this, except I didn't have the 2 choose 1. So on
You
the
didn't have-
S3.
S3,
Yeah.
you didn't have 2, choose 1.
Yeah.
Yeah, so they might have been missing something.
Yeah.
So you had minus this,
Yeah.
you had minus
Plus,
this, plus that,
yeah, without the 2 choose 1.
without the 2.
Yeah. So
Okay. Yeah. Yeah, those formulas are pretty handy. That, so is that good, Hope?
Yeah, that was super helpful. Thank you.
Yeah, at first I was like, oh man, I can't believe I gave that to them. But I talked about it. Yeah, right. Yeah, I talked about it. I'm having a hard time keeping track of what I point. Okay, what else? So Ilona, can I just ask, have you been able to at least watch the videos?
So not from today. So yeah, I've been like, all my classes are using this like ensemble thing. And I don't
Okay.
know, it might be working for everyone else, but it's like a no-go on my computer. So
It's just been pretty rough.
fine. Yeah.
Can you watch it on your phone? Oh wait, that would still be on a network. That's still going to be the same issue.
Yeah. Yeah. I finally like downloaded something from Social Movements. It took like 2.5 hours. I'm like, oh, I don't really
is that
have that
with,
kind of time.
Is that with Murray Murdoch?
Yeah. Yeah. And so like all the, like the download option, maybe.
Oh
it wasn't
man, Dr.
fast
Murdoch
enough.
is having to do a bunch of videos. That's
I
amazing.
know. I feel so bad for him.
Yeah.
Why Mrs. McDaniel is probably like really having to help him with that and everything.
Oh man. Yeah. Yeah. Yeah, so I mean I have most of them. Well, here, let me let's see. So create. I've been just trying to slowly go through this. So I'm doing 2 things at once here. By the way, whenever something in class, and these class meetings happen, it's like relevant for, everybody. I'm always, I'm gonna upload these, right? I'll just upload them into class, and I just label them, and I don't put any date on them or anything. I just put them in there. I put a date in the title, but I don't want you to think that it's like something that's due necessarily. So, let's see. No, it's not for kids. Which I don't know. Why do they ask me that? Huh. Okay. Okay. I guess a kid could watch this. You guys are kids. You guys should have said yes. Okay. So, all right. What else? Other questions? What else do you have?
Mm.
Hey, Ellie, can we revisit? Oh, by the way, I put up office hours from this morning because Ellie and Elise were peppering me with questions. So I put that up in there. Can we talk about 27 again?
Yeah.
Because I'm perplexed by this answer that's in the back of the book.
And I
Okay.
talked to Katie about that.
Confusing.
Huh?
Yes, Elise explained it to me.
Katie figured out why there was a discrepancy between what you were saying and what was actually in the book.
I think it's because I was considering the dice to be distinguishable,
Mm-hmm.
like a red and a green dice, which is usually the way things work. But I think they're not doing that.
Yeah, I think it said that they're identical. So
Okay,
that's the
yeah.
whole problem.
Yeah, okay. So, all right. So how many, so that changes things, right? I mean,
Mhm.
the process is still the same, right?
Yes.
What,
That's how many options there are.
they don't even say the range of K. But yeah, the number of options is going down. So why is the number of ways to roll indistinguishable die, why is it 21? Can someone explain that? Apparently Katie can.
So I think the way I was thinking of it is like, so if like you start with a 1, there's 6 options of things you can pair with 1. I'm trying to remember. It's been a while since I did it. And then yeah, and then for 2, because you've already paired the 1 and the 2, you only have 5 options of things you can pair with the 2. And then with 3, there's 4 down to 6. By the time you get to 6, the only option is 6, 6.
I see. So then yeah, that's why you get 21?
Yeah.
Okay, yes, that makes sense. Right, do you guys understand what Katie is saying? It's like 1, how many partners are there with 1? Well, there's 6, okay? And then with 2, you don't want to include 1 again. Does that make sense? You don't want to include 1 again because you already did all the ones with 1. With 2, how many partners are there with 2 that are 2 or more? 5. So it's going to be like 6 plus 5 plus 4 plus 3 plus 2 plus 1. Is that right? 6 plus 5 is 11, plus 4 is 15, plus 3 is 18, plus 2 is 20, plus 1 is 21. So there's 21 total possible outcomes. But they have like a weird formula that I still don't really know why, because it says they're thinking about it like a donut problem. How? I'm wondering about that. How are they doing that? They say that it's 2 plus 6 minus 1, choose 2. What's up with that?
I don't understand what their point is, but I mean, that does equal 21. So I kind of just interpreted that they were, that's how they found the number 21, and then they plugged it into the equation.
Can I just think about this for a minute? Hang on. Oh, I got it. Okay, so here's why it's 2 plus 6 minus 1. Imagine that boxes, okay? And each box is it represents the number on the die. So 1, 2, 3, 4, 5, 6, there's those 6 boxes. All I'm gonna do is throw a couple of balls in those boxes, okay? Ways are there to do that?
2 plus 6 minus 1, choose 2.
2 plus 6 minus 1, choose 2. Why does that uniquely determine an indistinguishable die roll?
Well, it's like you have your 2 distinguishable die that you're assigning
Yeah,
6 values.
it's like my indistinguishable die are those 2 balls I throw in those 6 boxes. If one of the balls falls in box 1 and one of the balls falls in box 3, then what roll did I just do?
1, 3.
1, 3. Does that make sense? So each one of those distributions of those 2 balls into the 6 boxes corresponds to an indistinguishable die roll. So it's 2 plus 6 minus 1, choose 2. So that's interesting. I was not thinking about it that way, but that's all it does is it kind of changes the number inside that's raised to the end. I think I had 36 before. Now it's 21. Yeah. But I think what we did before is exactly the same though, Ellie, right? It's exactly the same outside of that. We have these 6, K goes from 1 to 6, right?
Yeah.
Or something.
From 0 to 6.
0 to 6, yeah. So good. I'm glad we got that sorted out. So the difference is it was indistinguishable die. Okay, they are identical. I can't tell them apart, for crying out loud. Okay. All right, so what else? Other questions? Everything. Okay, I'm 2 videos away from having everything on YouTube here. Okay.
Could we go back to 25? So I did what you said with the DN from 33. But I can't. I have this n term or n plus 1 term and a -1 to the n term that I can't get to change into an n minus k.
Okay. Here, let me start the upload of this, and then I'll head over to the board here. Because that's going to be too nasty to write in on here. Okay. So let's see. You still see me? Do you still see me?
Yeah.
Let me see here. All right. You get rid of this junk on here. So I think we had decided that, okay, so how many arrangements of the integers 1 through n are there in which I is never immediately followed by I plus 1? Immediately followed by I plus 1. Okay, so we defined A1 is equal to the set of things like this. They go, you know, there's a 1, 2 somewhere, right?
Mhm.
That would be bad. If 2 was immediately followed by 1, that'd be bad, yes? Okay. And A2 looked like this. It was like 2, 3, and then stuff. Yeah? Is this what we were doing earlier?
Mhm.
Okay, and in general, well, and the highest we could go would be like, you know, n minus 1 n, and then et cetera. Yeah?
Mhm.
And we said, we don't want this. So we want the size of A1 bar through AN minus 1 bar. Yes?
Mhm.
So this is the size of the universe. How many things are in the universe here? How many arrangements of the integers 1 through n are there?
And factorial.
Yeah. So this is n factorial minus, it's pretty clear that all of these are going to have the same size. You know what I'm saying? They're all going to have the same size. There's n minus 1 of them times, okay, n minus 1 of them times, okay, how many arrangements are there with, now, you know, I'm actually working with sets AI themselves. How many are in the, well, let me write it this way, a size of A1, okay? And then it's going to be plus, and this is where we kind of had to put our thinking caps on a little bit and say, is what, okay, so like A1, A2, if I intersect A1 with A2, what does that mean? Intersect A1 with A2, what does that mean? What was that little hand roll? Was that hand up or like I have a question, Hope?
Oh, I
Okay.
like the applause reaction. I just
Okay. Awesome. Oh, okay. Good. So, so what about A1 and A2? If I intersect those, what does that mean is going on with my permutation?
And you have like a 1, 2, 3.
1, 2, 3. So I can think of those as being glued together. Well, okay. Yeah, I can think of those as being glued together, right?
Mhm.
And essentially 3 numbers are being treated like 1. So the total number of numbers has gone down by 2. Yeah? And so there would be n minus 2 factorial ways to arrange those. But the thing is that's also true even if I was A1 and A5. I would have a 1, 2 and a 5, 6. And those 2 numbers would become 1. You would glue them together. Does that make sense? So how many numbers would I still be decreasing by?
You're still going down by 2.
You're still going down by 2, but you have to at least think about that, right? You have to at least sit there and think about that to make sure that, you know, the intersection sizes are all the same. But what's the size of A1? The size of A1?
N minus 1 factorial. Like you're gluing them.
Okay, and then the size of then is it going to be n minus 1 choose 2 times the size of the double intersection, right? Because I have to choose 2 sets to intersect. What's the size of a double intersection?
N minus 2 factorial.
Okay, and then it's minus. You see the pattern, right? It's going to be minus n minus 1 choose 3 times n minus 3 factorial. Is that right? Is this what we had before,
Mhm.
and Elise? Okay. What's the last one going to be?
N minus 1 or it'll be 1, but we could write it n minus 1, choose n minus 1 times n minus n plus 1 factorial.
N minus 1, choose n minus 1. It's minus 1 to the n minus 1, right?
Yes.
And it's n minus n factorial, is that right?
N minus n minus plus 1 factorial.
Well, but the size 1 intersections, I had n minus 1 factorial. The size 2 intersections, it was n minus, oh, you're right.
Oh.
Yeah, you're right. It's n minus quantity n minus 1. Yeah.
Yeah.
Yes, thank you. Okay. So that's the formula that you end up with.
Mm-hmm.
And how did we simplify that?
If you turn the combination into a fraction, like the n minus 1 factorial over the lower number of factorial times n minus 1.
Yeah, n minus 1 choose k times n minus k factorial. You guys see that?
Mm-hmm.
So this is going to be n minus 1 factorial over k factorial n minus k minus 1 factorial. Yeah? N minus k factorial. Makes sense? So it looks to me, like everything but the n minus k like cancels, doesn't it? So it's n minus 1 factorial times the uppermost factor of this divided by k factorial. Do you believe it? You believe that?
Mm-hmm.
Yeah? So let's take this one step further. Shoot, I ran out of room here. Let me go up here. Equals. Look, if I distribute the n minus 1 factorial to these things, what's n minus 1 factorial times n? What's that?
N factorial.
That's just n factorial. So I'm going to have n factorial over k factorial. I have n factorial over k factorial. Yes. Minus what?
N minus 1 factorial over k minus 1 factorial.
Yes, because what cancels?
The k and the k.
The k and the k factorial. Yeah? So it's minus n minus 1 factorial over k factorial. That looks mysterious. That is very suspicious. Oh, oops, what I wrote something wrong there. What should I write?
K minus 1.
Yeah, because the n minus 1 factorial goes through, the k and the k factorial cancel, and you get this. That, my friends, looks a lot like something that I see. Well, so what does that? So what does that mean? Let's look. Let's rewrite those. So in other words, incidentally, like this n minus 1 right here. How should I write this? I mean, I might as well just write it how? How should I write this?
Minus 1, choose 1.
N minus 1, choose 1, right? So that this formula applies no matter what. Okay? So why am I doing this? Well, watch. Can I just write this out? This is what I meant by this is going to just be a pure algebraic thing here. So, so this is like n factorial minus, so what's this newfangled formula I just came up with? Minus what? n factorial over, right? I mean, we figured out what this thing was for any k. Yes, it's always this. Does that make sense? We figured out what this thing was for any k. This thing for any k is given by that formula. Yeah. So what's the first thing going to be? N factorial over
1 factorial
1 factorial
minus n minus 1 factorial
over what?
over 1 minus 1 factorial.
Yeah. Okay, over 0 factorial, I guess. Okay. And the next summand, what's the next summand?
N factorial over 2 factorial.
Minus?
N minus 1 factorial over 2 minus 1 factorial.
Oh, okay, so 2 factorial over 1 factorial. Yes? Okay. Well, that's extremely curious. Okay, so, and then what's the next one?
Then like n factorial over 3 factorial minus n minus 1 factorial over 2 factorial.
I'll just say plus dot dot dot, but let's see if we can discern a pattern down here on the bottom. Can you guys still see this? I mean, I hope you can. By the way, this whole thing looks backwards to me, and it has forever. I'm always nervous that it's not looking forwards to you. It's completely backwards to me. Is it forwards to you?
Yeah.
Yeah.
Huh?
Looks fun to us.
Because when I write, it goes backwards. Okay. So hey. Yeah. What is this? Well, like, look at the formula. Do you guys have your books in front of you? Look at the formula on page 333, down at the bottom. We counted the number of derangements at one point. Okay, Dn, let me just kind of write it up here at the top of the, where do I have any room? I guess over here, maybe. Okay, Dn is equal to, the number of derangements is equal to n factorial times, now let's look at this. If I plug in 0, it's going to be, so it's like 1 minus, well, that's annoying. So it's 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus dot 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 plus, what's the last, plus minus the n, 1 over n factorial, close parentheses. Okay, that's the formula for derangements there. Doesn't that remind you of what we have down here? Right, so look at that formula for derangements. It's like n factorial times this alternating sum of 1 over various factorials. You see that? So doesn't that look kind of like what we have here? Yeah? Okay, for instance, let me just convince you of that. Let's collect all the terms that have a factorial in them. Okay? Collect all the terms that have a factorial in them, including like this one. Okay? So, and don't, okay, one of the devil's in the details here, one of the biggest mistakes you could make as a mathematician is to destroy patterns that exist. So a big mistake you can make would be to cancel these things right here. Just like up here, you know, we could have canceled 1 over 0 factorial minus 1 over 1 factorial, but we left it in there because there was a sort of a pattern implicit into what was going on. Okay, so what is n factorial going to be multiplied by? What is n factorial multiplied by?
1 minus,
Right, so let me write that as 1 over 0 factorial. Minus
1 over 1 factorial,
plus,
1 over 2 factorial, dot, dot, dot.
hey. Isn't it just going to be minus 1? The last one is going to be minus 1 to the, because look, the sign on the thing is, it has the same parity as the number that's down here, yes? Last one's going to be, in fact, well, what is the last one going to be, I guess? Is it minus 1 to the, what's the last one going to be?
Minus 1 to the n.
Is it going to be minus 1 to the n?
We had like n minus 1 sets,
Yeah,
right?
n minus, isn't it going to be minus 1? Oh, hang on. So minus, so what's the last, maybe I should have written the last thing in here. What is the last thing? So plus, it was minus 1 to the n minus 1. What was the last thing? That, minus 1 to the n minus 1, and what would it have been? N factorial over,
N factorial?
huh?
Is it over n factorial?
Oh,
Wait,
oh.
just kidding. N minus 1 factorial.
I think it's in, I think it's because it was this guy, yes?
Mhm.
So k was n minus 1.
Yeah.
So it's n factorial over n minus 1 factorial. What? Minus,
Yeah. Minus
running out of room on the board here. Minus what?
factorial. N minus 1 factorial over n minus 2 factorial.
So what's the last thing I'm going to have here that has n factorial attached to it? So I was trying to figure out, it's going to be minus 1 to what power?
To the n minus 1.
Yeah, sorry. I mean, man, what is happening here? Oh, yeah. So, okay. So, I'm trying to keep that separate. Yes. Minus 1 to the what?
Minus 1 to the n minus 1 times 1
Times-
over n minus 1 factorial.
Close parentheses. So that's what n factorial is attached to. Yes. Okay. And what about the stuff that has n minus 1 factorial attached? So you distribute this negative sign. Okay, so it's going to be plus n minus 1 factorial. Okay, and isn't there a 1 over 0 factorial?
Yep.
Yeah. And then what?
And 1 over 1 factorial.
Minus 1 over 1 factorial.
Yep, plus 1 over 2 factorial.
Plus 1 over 2 factorial. Minus dot, 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 plus what's the last thing that's going to survive here?
Is it minus 1 to the n minus 1 or wait.
Minus,
Yeah.
okay.
Minus 1 to the n minus 1 times 1 over n minus 2 factorial.
Is that right?
Wouldn't it be minus 1 to the n since you're also multiplying by another negative?
Oh, yeah, it's minus 1 to the,
Oh.
it's minus 1 to the n because there's a minus sign and there's n minus 1 negative ones here.
Yeah, that makes
But
sense.
to make it match, minus 1 to the n is the same as minus 1 to the n minus 2. N and n minus 2 have the same parity. So it's going to be minus 1 to the n minus 2 times what?
Times 1 over n minus 2 factorial.
Oh, okay. So what's this?
So n factorial times dn minus 1.
Well, but dn is, okay, so we have to be careful here. dn
Oh, yeah.
is n factorial times this thing where I go all the way to n.
Mm. Yeah.
So this isn't quite, this guy right here isn't quite dn, is it?
Is it n times dn minus 1?
It's n times dn minus 1, yes. And what's this?
That's plus n minus 1 times dn minus 2.
Yes, because it's n minus 1 times n minus 2 factorial times this stuff, which is just dn minus 2. What were we supposed to prove?
That it was dn plus dn minus 1, I think.
Oh, well, maybe we can make that happen. What term are we missing?
We're missing the plus, like the one that's 1 over n factorial.
Yeah, we're missing that one. So here, let me go up here. Watch this. This will be an easy fix. Okay, so the size, in the end, we showed that the size of A1 bar and all the way up to AN bar, that this is n factorial 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus dot 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 plus minus 1 to the n minus 1 times 1 over n minus 1 factorial. And then it's plus, is it plus? Yeah, it's plus. Plus n minus 1 factorial times 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus dot 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 plus minus 1 to the n minus 2 times 1 over n minus 2 factorial. And what do we want to, what would we like to see here and here to have dn? What would we like to see there to have dn?
Oh, you want a plus minus 1 to the n times 1 over n factorial.
Yeah, minus 1 to the n. So we would like to see a plus minus 1 to the n times 1 over n factorial, yes?
Mm-hmm.
And what would you like to see here?
Plus minus 1 to the n minus 1 times 1 over n minus 1 factorial.
Minus 1 to the n minus 1 over what?
Over n minus 1 factorial.
And here is the miracle, everyone. What's n minus 1 factorial times this? So think about this. If I take this guy and I put it to that, what do I get?
You can get 1.
What do I get?
You get like minus 1 to the n minus 1.
And if I take this n factorial and I put it to that, what do I get?
Minus 1 to the n minus 1.
Actually, it'll be, so this extra term that I want right here is going to be minus 1 to the,
Oh, to the n.
and what do these two things combine to give you? Minus
0.
1 to the n. If I add those together,
Add the 0.
0. Those two things give you 0. So what do I get to put in here for free at no cost?
The terms you want, yeah.
The missing term. Does that make sense?
Yep.
So what do you end up with?
dn plus
Yeah, you just
dn.
have straight, have dn plus dn minus 1. Yeah, it's crazy. And there is sort of an intuitive way to think about that, but it's, you know, it's like, because it's like when that sort of thing happens, you ought to have alarm bells going off. You ought to be like, what? That can't just be coincidence, right? But yeah, and there is an intuitive reason why that's true, but the algebra does work. It all comes down to that formula at the bottom of 333. Does that make sense, Ellie?
Mm-hmm.
Okay. Cool. That was exciting. I thought it was exciting. All right. All right, I'm going to unpin myself. I think I pinned myself there. Unpin. Okay. All right, what else?
You guys gonna have a math prof pizza party?
I don't
There's
think.
less than 10 of you, isn't there?
Huh? Well, yeah, that's true. I don't know. It's been kind of a bummer. I mean, we're all here. Interviewed another math candidate today, and we had to do it over Zoom.
Oh.
So I don't know. We're getting really good at Zoom, I think.
Yeah.
But I don't know. I mean, I just see it as a way to kind of help shape us a little, stretch us a little bit. Probably same with you guys. But I mean,
Yeah.
I definitely prefer doing stuff in person. No question about that. I don't know about you. Oh, what else? Anything else? I don't know if we can have a pizza party because we would just give each other coronavirus.
Yeah.
How was the candidate?
I mean, I was really pretty impressed. I think that we're probably going to have her do a lecture, and we might commission some students to do that live on Zoom or something. And I think that might be what we try to do. But I was pretty impressed. So what do I know, right? So we'll see how it goes. What else? Do you have any other questions? Where's the other slackers in this class? What's going on here? Is this homework just way too easy or something?
I think some of them are prioritizing the exam.
Ah, I see. But the exam's not too bad, is it? No. Hopefully not. Okay. Did everything, did the questions at least make sense on there to people?
Mm-hmm.
Yes, there was one though I had a question about, and I can't remember which one it was.
Okay. Ask.
Let me remember which one.
Oh, are you looking right now?
Yeah, sorry, I'm just remembering which one. So it was the one where you were inviting all your friends over for dinner.
Uh-huh.
And I just wanted to clarify, like, the order in which you invite them over matters, right? Like,
Yeah, because
invite
that's
your
going to be a
friend one-
different, because that's going to mean like a different night or something, right?
right, okay,
Yeah.
cool. I just wanted to make sure I was thinking about that correctly when I did it.
Mm-hmm.
Yeah. But I was thinking they were probably, distinct.
Yeah.
Okay.
By the way, the one about, let me see here. I remember there was one that I was solving at one point, and it was horrible, and then I made it a lot easier. Oh, wait.
Number 32 on this homework was really similar to that one, I thought.
Oh, yeah, the friend inviting problem.
Yeah.
Yeah.
No tennis match.
Yes. It's like the same problem.
Yeah.
That's one reason to do your homework first. Oh, it was the recurrence. It was the recursion problem. Like part B of the recursion problem. At first I had it. At first I had it where you were going to solve for the coefficients, but that was just brutal. I mean, I did it, but it was horrible. And I mean, I was excited when I did it, but I just thought, man, that is just bad. So all I did was I just said, find the general solution without, so don't find the coefficients, what I'm saying. Know what I mean?
Mhm.
Okay. So that was horrible. But the first one shouldn't be too bad. If you're having to do a lot of horrible things on the first one, then I doubt your methods. So, did you like my problem about the soccer teams?
I loved
A
it.
while to think of, so yeah, I like that one. It's not a super difficult problem, but it's and I think that one is kind of like the tennis match problem also in some ways. So, yeah. All right.